on the data structure one problems with I did yesterday with the other one, right? So let me try to remember. Yesterday what we do like with simple list, but today we we're going to do the same pattern, but like we're going to merge the node list. So this one is like a merge list. Let me read the problems now. Write a function merge list. Write a function merge list that takes in the head of two sorted linked lists. Two sorted linked lists. Okay, two sorted linked lists. So it means we already have two lists of nodes, right? And then both already sorted. Okay, the function choose merge the two lists together in two single sorted linked lists. The function choose return the head of the merged linked list. Okay, do this in place by mutating the original nodes. You may assume that both input lists are non-empty and contain increasing sorted number. Okay, so from I see the example here, we have two nodes, right? So we have 5, 7, 10, 12, 20, and 28. And the second node is like 6, 8, 9, 25. Both already sorted. But then what we want to return like the merge together, only one single list, and then they should be in order like merging. So what my approach I'm going to do here, I'm going to have like the empty like a dummy node to check to keep track of both nodes, and then we will use that empty node to refer and then gonna return at the end. And then we're gonna compare between current node and the head node 1 and node 2, right? So both of them need to refer to the reference to current 1 and current 2. Current 1 I will set to be the head 1. The current 2 will set to head 2. And then also I'm gonna have a tail to set to the dummy node. And then that's why while we checking in logics algorithm logical, so we need to sweep them and sort them and that. Okay, so let me write code now. So like I say, I'm going to have dummy node with like set to new node, and then I just gonna add nodes here. Okay, that's one. And then I'm going to have the tail, which we're going to keep track of moving tail. Each time we travels to the list. So the tail I'm gonna set to dummy node, right? And then we're going to have current 1, and that I'm going to set to the head 1, and then current 2 I'm going to set to head 2. And I know at the end we're going to return something, but we will work on that later. So come to the logical travels to the node. So we're going to check if both current 1 and current 2 are not known. Okay, if both of them, it means current 1, okay, current 1 is not known and current 2 is also not known. That's what we're going to do some our algorithm here inside value, right? And then we're going to check which node is greater because we want to sort, right? If there, okay, so what I'm gonna check here, if the current 1, this means the list 1, the current node 1 that value, if this value is less, then it should be, yeah, it's less than current 2 dot values. What we're going to do here, we're going to move the tail dot next, right? We have tail set to dummy node, right? So tail dot next will be current 1, right? And then we need to reference point the link to current 1 dot next. going to point to, let me think, what's we going to point to? Okay, we want to keep track, current.next. Oh, sorry. We want to move tail.next to the current node, right? Current one. If the value of current ones is less than values of current two, we want to move tail next to the current one, and then we want to keep current one to move to current.next, current one.next. In the other side, else, if there are, if the value of the current two is less than, right, it's just else, right? We're going to move tail.next to current two, and then we want to keep current two and move to current two.next. Okay, and then we know while we travel and checking our logics, like which one is greater than that one, is current sourcing. So we want to move tail to tail.next. Okay, you need to be concerned about if both links is different length, if the other one is longer than others. So we have to check if current one is not known. We want to keep like tail.next to all of current ones, right? And other things too, like if current two is not known, we want to keep the all of current two. At the end, we want to return dummy, but then we need to, like, because the dummy node is just null, right? So we want to return when we changing or rotate anything. After that logic, we need to return dummy node.next. Okay, this is iterative solution. I'm not sure, like I will run a test if it's passed. If not, we can try to figure out fixing bugs later. Okay, so at the time compress, let me just run the code first. Okay, that's passing test. So for talking about time complexities, because we have two lists, so the time complexity gonna be all of n, like linear times, but minimum of the ones of m or n, because this one is less, right? So if we have the shorter ones, it means we're gonna run to the shorter one, and the rest we just merge to the one we already have. So it depends minimum of the longest, like both lists. And for space complexities, it's gonna be O of 1, because we do in place, right? We don't really have order variable or like using any space, so the space is just gonna be O of 1. We use just some variable, it's just be outside of the while loop, right? So that is O of 1. So thank you for watching. I will see you in the next video when I try to working on this. Thank you. Bye.